Okay, let's jump into something truly unexpected today.
Definitely.
When you hear advanced mathematics, your mind probably goes straight to, I don't know, complex physics, maybe crunching market data.
Sure, the usual suspects.
But what if I told you we're doing a deep dive today into how a core concept of calculus
Hmm.
is used to figure out, well, how much manure a cow produces?
It sounds counterintuitive, right? Almost a bit funny.
It does.
But our source material today lays out a very specific application. It's about mathematical integration in agriculture.
Exactly. So the mission for this deep dive really is to unpack why and how.
Hmm.
How does a tool like integration, which feels so abstract, get applied to something so well grounded, so physical, like calculating output from cattle?
And the source narrows it down even more. It's not just any cattle.
Huh.
It focuses specifically on cattle raised on silage from agricultural fields.
Silage, okay, so that's like fermented feed.
Exactly, fermented crops.
Yeah.
And the source details using integration as the method to evaluate their total manure output.
Right. So this isn't just a simple, count the piles kind of estimate.
Definitely not.
The source suggests there's complexity here, something that needs a more sophisticated approach. Why integration, though? What specific problem does it solve here?
That's where the source gets interesting. It explains that the rate a cow produces manure, it isn't constant.
Okay, that makes sense.
It changes throughout the day, maybe depending on when they ate what they ate, like that silage.
Right?
So instead of just measuring the rate at one single moment and multiplying,
Which would be inaccurate.
totally,
All right.
integration is used to accumulate all those little changes
Yeah.
to sum up that varying rate over a specific period.
Ah, okay. So that gives you the total output.
Precisely.
It's like calculating the total distance a car travels when its speed is always changing, right?
Yeah, exactly that.
You integrate the speed over time. So here you're integrating the rate of manure production over time
Mm-hmm.
to get the total volume or weight. Makes perfect sense when you put it like that.
And the source highlights this need for precision because, understanding this total output isn't just some academic exercise.
Right, connecting this back to the bigger picture. Why measure manure output so precisely? What's the practical point?
Well, the source points out this is actually crucial for effective agricultural management.
Okay.
Manure is a really significant byproduct. Its volume, its composition, they affect nutrient cycling in the soil.
Ah, right, for fertilizer potential.
Exactly. Potential uses fertilizer maybe on those same fields where the silage came from, plus managing environmental factors.
Like runoff or emission.
Yeah, things like runoff or greenhouse gas emissions. Accurate measurement using methods like integration helps farmers and environmental scientists too
Yeah.
quantify these impacts, helps them plan.
So what this deep dive really shows you then, it reveals that mathematical concepts like integration, they're not just stuck in textbooks.
Not at all.
They're not just for theoretical problems on a whiteboard. They are practical tools. Tools used to understand and quantify real-world, sometimes messy,
Definitely messy in this case.
and sometimes surprising phenomena like, the output of cattle on a farm.
Yeah, and this specific case, the one detailed in our source, using integration for manure from silage-fed cattle. It just underscores how versatile these advanced mathematical methods are.
Versatile and essential.
Essential for evaluating tangible processes in fields you might honestly never associate with calculus.
It really is fascinating. It sort of challenges that common idea that higher math is purely abstract, doesn't it?
It does.
Instead, it's this powerful lens, this tool set for dissecting the physical world all around us, right down to the farm level.
It makes you wonder, doesn't it, if integration is being applied here?
Yeah.
Where else are advanced mathematical tools solving practical problems basically in plain sight, but we just haven't noticed them yet?
That's a great point. So maybe next time you're thinking about calculus, don't just picture rocket trajectories or stock market curves. Picture agricultural fields, too. Picture the complex biological processes happening right there. It's a vivid reminder that math is truly, surprisingly, everywhere.